Hello, and welcome to Exponential Functions. My name is Tuesday Johnson. Here are the applications. I always forget the button. Isn't that crazy? So let's talk about continuously compounding interest. The number E is a value in mathematics named after the Swiss mathematician Leonhard Euler. I know, it looks like Euler. It's Euler. The number is defined by what's called a limit. And if you take the second part of math for the social sciences too, you'll find out all about this. But for now, we're just going to call the number E. Euler did not name it after himself. I believe it was Bernoulli that gave him that honor, one of the Bernoullis. And this is an irrational number. It's like pi, but not the same value, but the decimal never ends. So we'll use E in place of it, just like we use the symbol pi when we mean the number approximately 3.1415927 and so forth. So continuously compounding interest uses this number E. If P dollars are invested at an annual rate of R compounded continuously, the total accumulated amount after T years is given by A equals P times E to the RT, where E is this E. All right, I call it the PERT equation. Let's take a look. All right, the Bank of Mama, the best bank to go to, is offering an account that pays 4% compounded continuously. How much interest would a $1,000 deposit earn over 7 years? Well, first we're going to identify our variables. We know that A equals P times E to the RT. So our P value, that's the initial deposit, so $1,000. Our interest rate is 4%, and we will always convert that to a decimal, 0.04. And the time looks like it's 7 years. Substitute this into our equation. We'll have A equals P, which is 1,000, E to the RT. Notice that I put in parentheses my exponent to make sure the calculator carries out the operation correctly. E is a button you'll find on your calculator. Find where the LN button is, and I bet E is going to be a second function of that. And we end up with $1,323.13. But let's reread the problem, right? Anytime you're answering a question, make sure you've answered what's actually asked. I'm being asked how much interest, but this A is the entire future amount. Well, if my future amount is $1,323.13, and I deposited $1,000, then only the $323.13 is interest. Right? Are they asking for future amount or are they asking for interest? Make sure you answer the question that is being asked. Wow. Okay, so let's find an exponential curve. Many times you'll be asked to find an equation of the exponential curve through 2 points. And normally I would do this on a calculator with exponential regression. But for the purposes of this video, I'm going to show you how to do it by hand. Okay, so to begin with, we write each point in the exponential form of y equals a times b to the x, leaving a and b as our unknowns. So we'll have 1.2 equals a times b to the first power, and similarly for our second point. We're going to solve one equation for a, so we're going to do this like a cyclone thing here. We're going to circle it completely around. Let's solve the first equation for a. A equals 1.2 divided by b to the 1. You know, mathematicians like me, a little lazy. We don't ever write a 1 power, but it's always assumed to be there. We're going to take this result and substitute it into our other equation. So instead of an a, we'll have a 1.2 over b. We want one equation that goes through both points, so the same a and b on the left is the same a and b as the right. When I simplify, I end up with 0.108 equals 1.2 b squared. Now we can solve for b, right? It's the only variable we have. So 0.108 divided by 1.2 equals b squared. We'll take the square root of both sides, and we'll get b equals 0.3. We can now take this result of b, take it back to the first equation, so we can also solve for a. Now we have a equals 1.2 over our found value of 0.3 to give us an answer of 4. If we put this together, our b value of 0.3, our a value of 4, we've completed our circle And we now have y equals 4 times 0.3 to the x. All right, so we can find the equation. I encourage you to use technological resources to do so, but if necessary, you know how to find an exponential curve by hand as well. So when might we use these exponential functions? Tylenol happens to have a half-life. That means it's a certain amount of time for half of the substance to decay. This one patient, soon after taking a Tylenol, a patient has absorbed 550 milligrams of the drug. After 2 hours, only 333 milligrams of Tylenol remains in the bloodstream. We want to find an exponential model for Tylenol in the bloodstream after T hours, and then we're going to use our model to find the amount of Tylenol in the bloodstream after 5 hours. And this, by the way, you can look it up, but this is truly the half-life for Tylenol. I decided to be accurate. So as we look at this, Tylenol, a patient has absorbed 550 milligrams of the drug. So soon after taking, so at time 0, they start with 550 milligrams. After 2 hours, only 333 milligrams of Tylenol remains, will give us the point 2, 333. Well, now that we have 2 points, we can find the values of A and B, and we can find an exponential model for the Tylenol. So given these points, we have, well, the first one, if we put 550 in for y and 0 for x, we'll have 550 equals A times b to the 0. 550 is equal to A times b to the 0, which means that A must be 550. Why? Well, remember that b is not 0. It's a positive number. A positive number raised to the 0 power is going to be 1. 1 times A is A equals 550. We also have the second point, 333, is equal to A times B squared. Well, we know that A is 550, so we can put that in there and we'll have 333 equals 550B squared. From there, we can solve for B by dividing both sides by 550. Once we have 333 over 550 equals B squared, we can take the square root of both sides. When we take the square root, we'll end up with about 0.7781. I went to 4 decimal places because that's really what you need in order to be accurate. And if you go at least to 4 decimal places, you'll be good for most of your homework assignments. So we could put this together. We have our A, we have our B. We know that our function, f of t, because it's dependent on time, equals 550, parentheses, 0.7781 to the t power. And when t equals 5, we'll just substitute a 5 for the exponent, and we end up with 156.8699. But what does that mean? This means after 5 hours, they will have about 157 milligrams of Tylenol remaining in their system. All right, so this is great for a lot of people, but it's also great for anybody that takes Tylenol. Now you know when your levels will need replenished. That's it for exponential applications. Thank you very much for watching.